Fantastic. We have Darren and Cosimo from BP's Castrol Immersion division. I need you guys to give me a little background or context of what that looks like.
Absolutely. Do you want to go ahead?
Sure, yeah. So Castrol, obviously wholly owned subsidiary of BP, well-known worldwide lubricants company. And I guess close to 3 years ago now, I formulated what we call the thermal management business unit. And so thermal management started with full single-phase immersion cooling. 3 years ago, that was hugely adopted, over 500 megawatts, in fact, in Bitcoin mining, in fact.
Wow.
And was really coming on strong in data centers, and kind of took a step back to what's known as direct-to-chip or cold plate liquid cooling. And we've kind of embraced the whole thing. As a chemical company, we offer all those fluids, fluid management services. And so that's kind of where we're coming from.
And the immersion technology, how was that developed?
Immersion technology, it's there's been different flavors of it around, coming almost from both Cray computing and also a bit into the gaming.
In relation to AI data centers and scaling data centers, how does that apply?
As Darren said, liquid cooling in general has been around for 40 years, 50 years.
It's incredible.
Since the dawn of actually the mainframes.
Yeah.
So it's not a new technology. And even immersion goes back. The difference here is the adoption at scale, as you were mentioning, with AI, that generates so much heat that air just cannot do it. So,
yeah, exactly. Air's no longer adequate. So in the case of AI, you've got to embrace liquid cooling.
So where are we in the adoption of this?
We were just talking about the major hyperscalers, the names that affect our lives every day have been deploying this for probably 4 years now.
Okay.
Yeah.
So most of their...
So there's actually much more than people know.
Yeah.
But the companies that are doing this don't like to broadcast what they are doing, and we cannot talk about our customers. We have NDAs with everybody.
And there are people in Italy that would find us. And
there are people in Italy that have baseball bats and have knees, so I like to keep... No, which is one of the challenge of this industry, because we were actually talking about that on the stage a few minutes ago. The market is made of very large companies that we all know, and they all think that they are unique and special and smarter than anybody else.
Right.
I don't want to say that they are doing all the same thing, because there's like the difference here and there. But I mean, the technology is basic technology.
Revolutionary. Let me ask it this way then. Stepping back a layer to the enterprises, what are the design considerations they have to consider?
Wow, it's really interesting. So you're talking about a plate on top of a chip stack, and the heat transfer right there that's where all the action is.
Yeah.
And so, what is this plate made of? How thin is the metal? What kind of grease or metallic paste do you put in between to help things out? How fast can you run the liquid inside? How small are the channels? Big are the channels? How are you pulling the heat out back there after you pull it out at the little spot? There's a lot going on.
What viscosity are we running at here?
It's essentially water.
It's essentially water.
Yeah.
Viscosity is not. It's not a big challenge.
Yeah.
Yeah, the pump would blow up if viscosity were the challenge.
Yeah.
Okay, so what are the biggest technology challenges for you, and what are the biggest for your company then, for the companies you serve?
I would say the biggest technology challenge is, there's a few of them. As Darren was saying, the most common liquid cool technology is the cold plate. Now, with the cold plate, you cool down mainly the processor.
Right.
It could be a CPU, a GPU, it doesn't matter. But there's a large component of air-cooled steel involved. Now, you can actually put cold plates everywhere and cool and remove 99% of the heat with cold plates, but then maintenance of the server becomes complicated, because everything is covered by cold plates, and if you have to change a memory, you have to unscrew. It's complicated. So that is the first challenge. The second challenge, I would say, is that it's still kind of a new technology. Has been around for a while, but not at scale. The adoption is at a very early stage. You ask who is actually adopting these. there's not a 1 million server liquid cooled situation yet. It's coming in weeks, not even in months. It is happening right now, because it was a nice to have, and now, as Darren said, now it's must have. So
Give me an idea of how much we're talking about in terms of a efficiency or cost savings from moving to liquid cooling.
So immersion cooling is more than 40%. So we're moving back over to put the entire server down inside the dielectric.
Yeah.
Okay, you can put it in any room you want.
Yeah.
There's no more air conditioning really needed other than just to keep a basic comfort level. So all of that specialty air handling, everything you've got going on is all gone now.
Yeah.
So that's a massive savings. When you come to, again, the cold plate directed chip, you still got to cool the rest of the server. So the room, you still got the
thermal
air
management?
conditioning going on.
Does that have to do with a little thermal management?
Well, just, you can still got the memory parts of the server and everything else that are generating heat,
Yeah.
but those don't have the plates touching them. So,
Okay.
the whole server still got to stay relatively cool, probably a bit cooler than this room, just to keep everything going. So it depends which way you go, how much energy you save. But again, now it's flip-flopping, particularly in the United States, where energy costs are not that big of a deal, that you just simply cannot cool an AI chip without the liquid cooling. So it's a matter of necessity, regardless if you're saving water or power or anything or not.
Who's your customer?
well, as we said, we have NDAs with everybody, but I would say our main customers are the end users, the hyperscalers, for instance.
Yeah. So the top 10, 20 kind of companies in that space?
Well, no comment.
Okay, beautiful. Can't believe it. No. Who in the decision-making authority at the company? Is this a CFO decision, CTO, head of the data center? Is it engineering? Who do you talk to?
It really steps its way through because this is another important point that the big guys have been through, and then everybody else is coming to the reality is the complications you can have in the chemistry, even as simple as this PG25. It's propylene glycol commodity plus water. Clearly, there's plenty of that around, and a bit of additives thrown in for biofouling and for anti-corrosion. The problem is that bit of additives is where the magic is, and that bit of additives is different for just about everybody who makes it. And you throw two pieces of magic together, you end up with magic that you didn't want sometimes. So when you start to deploy this at scale.
That's a nice way of putting it.
Yeah.
This principle applies for everything, by the way.
Yeah. I mean, you start to deploy that at scale, and 3 years from now, you're like, oh, we got all sorts of magic here we weren't thinking about. We should have been checking this every 6 months. So that's a big part of the sort of overall management of the thing, and that it's a bit more complicated than just throwing a commodity fluid in and
So on
getting
the
things
buying
moving.
process side, you're doing a lot of tests with the companies and doing.
See, I completely forgot your question.
Yeah.
The point is, it starts with the engineers because
Yeah.
they got to deal with the magic,
Yeah.
and it goes all the way through to procurement because they got to buy millions of gallons.
Right.
And it's a stepwise process along the way.
Now take me a year or two out. What are we going to see, just in terms of like painting the roadmap and innovation?
I think we particularly, and we can't be the only ones, have some innovations going on with additives. Where it's going to increase basically the heat capacity of the liquid, so its ability to take more heat away without you can't add extreme expense. There's a lot of things going on with, again, as I mentioned, there's greases right now that you could put in between the chipset and the cold plate. There are metallic pastes. So some balance in there because the greases pump out as things expand and contract because they're getting hotter and colder. And how do you add that back in a running server? Metallic pastes don't pump out, but they're not as good. So how do you keep getting more heat out with just sort of this basic physics? Because there's only so much you can change about the physics. There's all sorts of wild ideas, but wild ideas don't make it into production, right?
And then I would say the other aspect that we have to consider is that air cooling is not going anywhere. So because we focus on the tip of the pyramid of the super high specialized GPUs for AI, but the vast majority of data centers don't do that. So that's the shiny new object, and it's where the money is going, but your picture of your pets and your kids they are not AI enabled. I mean, they don't demand super high. So
Right.
the future, the complication of the future is that it's going to be a combination of all the technology all together. 5 years ago, you had 99.9% air cooled. In 5 years, you're going to have a mix of different technologies in the same room, and you need to have you need to be ready to handle all of them, to maintain all of them, to fix all of them, and therefore, as we've said, you need to have a list of partners that you work with that gives you the confidence that you can do that at scale globally. Because we are talking about the US, we are talking about Indonesia, Malaysia, we are talking about New Zealand, we're talking about night shifts, we're talking about thousands of people that do thousands of things.
That's
and
fascinating.
It is gonna, accident is gonna happen. I mean, it's just
It has to,
life.
right, for energy purposes and.
I mean,
Yeah.
What's your biggest concern?
People ignoring the potential. Just like I said,
The potential,
when
not
you
the
make
risk.
when you make new magic.
Yeah.
I mean, because obviously, if you come with a clog, then suddenly you got pumps that don't run, and you got some real problems. But you know, it's kind of like the person who gets less healthy over. The heart attack doesn't come until there's plenty of signs along the way. But if you ignore them all, you end up with a heart attack eventually. Well, the whole system was running poorly a long time ago, and that's the same thing with these servers. The heat, you're taking less of it away. Everything's running, worse and worse and worse, and just saying, you can mix this stuff. It doesn't matter. There's nothing going on there. It's just a little chemical in water.
This isn't our father's BP or Castrol anymore, is it?
it's not. It's not. But actually, my biggest concern is that it's a different declination of what he said, actually.
Yeah.
And my biggest concern is what we were talking about before, that we need to share experience and information. We are not doing things so differently one to another. And the moment that we start actually sharing experiences and mistakes, the faster we solve those and we predict them.
Yeah.
This is my biggest concern, that everybody is keeping their cards very close to their chest.
Concern and opportunity. So good luck. I think you
Thank
you have the eye of the tiger and the chance to go make it happen. I like the race you're running now.
Thank you.
Thank you very much.
Thanks for coming by. Really appreciate it.
Thank you.
Bye-bye.